Welcome, everyone, to the 10th annual Martin Gardner Celebration of Mind event. Normally, we have several Celebration of Mind events physically around the world. This year, of course, everything is virtual, so we are happy to be able to share an entire week's worth of Martin Gardner-related talks for everybody over Zoom. And our first speaker today is Carolyn Yackel, who's going to be telling us some very cool stuff about orbifolds and folding and dyeing. And I'm going to hand this over to Carolyn and let you speak.
Excellent. Okay, so today I'm going to tell you about how orbifolds inform Shibori dyeing. And so Shibori dyeing is this Japanese process of dyeing, and actually it encompasses a whole bunch of different techniques. And I'm just going to talk about one of the techniques that's called itajime Shibori, and I'm really sorry if you actually know how to pronounce Japanese, so just forgive me. Okay, so this particular technique of Shibori dyeing imposes constraints on possible patterns, and my goal was to make every wallpaper pattern in itajime Shibori. So for those of you who might know, the wallpaper patterns can be classified into 17 different groups according to their symmetry types. And each one has an underlying orbifold structure. So when I say wallpaper pattern, I'm not talking about something like a mural where you could have like the picture of a bird over here and a rainbow over there or something like that. I'm talking about wallpaper where there's a repetition, so you're going to see the same image here as over there, and you could theoretically have this cover the two-dimensional plane. So you can imagine how it would extend out to the two-dimensional plane. Okay, but of course, we're dyeing a piece of cloth, which can't really be infinite because then it couldn't really exist in our world. So I want to sort of have these wallpaper patterns realized through this dyeing process. And so I need to think about what kinds of constraints are going to be imposed through my technique. And I'll explain what's going on with the orbifolds in a second. Okay, so, but there are constraints that come from this process. And it happens because in order to enact this technique, I actually have to fold the orbifold corresponding to the wallpaper pattern, and only some of the orbifolds can actually be folded. So let's figure out what's going on with this technique. Okay, whenever you dye something, a piece of cloth or whatever, like you might be submersing your cloth into, for example, a vat of dye. This could be what's happening. And so you have to, if you're not going to just end up with a piece of cloth that's all one color, say, you have to make it so that dye doesn't get into parts of the cloth. So how is that going to happen? Well, there are different ways of creating what's called a resist. Like in batik or something, you put wax on the cloth and then dye can't get where the wax is. Well, that's not what's going on in Shibori. In Shibori, what happens is you make it so that the cloth is really tightly stuck together in some way. And in itajime and seiko, what's happening is you're creating the resist by clamping the cloth in between sort of like plates or something like that. Lots of times, if you just buy this Shibori kit, so like Shibori has become something that people are doing for fun lots of times at home, and so that you can buy these kits, and what they do is they'll sell them with these blocks of wood, like 2 squares or something. You can clamp them together, and the clamping these pairs creates this force resist that keeps the dye out because it's clamped so tightly together. Okay, and so what you do is you fold your cloth, and notice when you fold, you're going to create a line of mirror symmetry or reflection, and then you put something on either side to create this force resist, and that's going to create this mirror. Okay, so notice the folds automatically create these mirrors, and another way to do it is to use rubber bands. And so rubber bands are going to remind you of tie-dye. Tie-dye is sort of like a kind of Seika, but anyways, the difference between tie-dye and what I'm doing is that with tie-dye, lots of times you wouldn't get a wallpaper pattern that would be like the same in all these different areas. And so what we want is something that's got repetition in like 2 independent directions. Okay, so I want the potential to repeat around a theoretically infinite piece of cloth, but also I don't want to make use of cuts. So I don't want to make use of the edges because we don't have edges on a theoretically infinite piece of cloth. And also I don't want to cut because if you use cloth a lot, you know that if you make a cut in a piece of cloth, you can't really sew it back together and not have a loss. And you can't glue it back together really well either. So that's another limitation. Okay, so the process looks something like this. Here there's these folded pieces of cloth and you can see that there's some clamped things. So I used jar lids and I clamped using binder clips to make it really tight. And by the way, if you do this at home, your binder clips get completely ruined by the process. So don't think you're going to be able to use them again, but it's super fun. So I do recommend it as a fun thing to do. Notice that we have to fold these orbifolds in order to make the wallpaper pattern that corresponds to the orbifold. So a good orbifold is the quotient of a group acting on a space. So in our case, it's the quotient of the group of transformations acting on the plane. So our cloth is like the plane, and we're taking the quotient of the group of transformations acting on the plane. And so what you want to think about is like, what if I had a picture of my wallpaper pattern on a really thin piece of paper? What I could do is I could try to fold it so that the wallpaper pattern lined up with itself so that you only had one copy. And what would that look like? And when you folded it like that, it would look like the orbifold, okay? The question is, what orbifolds can you create like that without doing any cutting and in 3 space? We'll have designs that have reflections, but no pure rotations. So in order to get pure rotations, you have to cut. You have to cut in order to get what are called CoM points. And also we have to be able to fold the orbifold in 3-dimensional space. So the problem with the CoM points, the cutting, is that, you know, just try to think about having a piece of cloth and like having a point where you have just rotation. If you try to rotate it around your point, it doesn't work. Just try it out. It doesn't work. Okay, so of the 17 wallpaper patterns, 8 of them have these cone points, or points with pure rotations. And then 2 of them, the orbifolds, are things that don't live in 3 space, the Klein bottle and the projected plane. So if you're counting, that's 10 of the wallpaper patterns we just can't get. 8 because of CoM points and 2 because the orbifolds don't live in 3-dimensional spaces. So that leaves us with 7 wallpaper patterns that we can get, and we're going to look at these. Okay, so the first one I want to look at is the mirrored annulus. And so that's actually this one. And so what you want to do to make it is, you know, you just make a bunch of folds. And for those of you who have done origami, you know, you want to make these folds as accordion folds, because otherwise your fabric gets all bunched up and then your folds aren't very, they're not very accurate anymore. And then you just wrap it around to make an annulus or a cylinder. And then you put some clamped things on there, and then you can get the thing at the left, which is a dyed realization of the wallpaper pattern. And you might look at it and say, well, you know, that doesn't look as accurate as the digitally generated wallpaper pattern on the right, which is totally true, right? Of course, it's going to be more accurate if you do a digitally generated wallpaper pattern, which is what makes the Shibori thing kind of fun in a way. It's more like art. Okay, the next one is the mirrored Mobius. And for that, you just kind of do the same thing, where you start with this strip, you know, this accordion folded strip, but now you have to fold it into a Mobius band. And so it's like tricky because you have to wrap it around itself as a Mobius, but that's okay. And I like to call this one the monster because it looks like a monster and then it's offset. Then the next one was really simple. You know, you just fold it into a rectangle, but you have to do accordion folds. And then here you're folding, your orbifold is just a right triangle with mirrored, the edges are mirrors here. And then this one, which is really fun because you have, you know, these reflection centers with order 3. This one, if you've tried to fold hexaflexagons before, you've done something like this. So, you know, you start out with your accordion folded strip, and then you just fold these 60-degree angles. And then the next one, your orbifold is a 30, 60, 90 triangle. So you actually just fold it like the previous one, and then you just fold everything in half at the end. But you have to maintain your accordion folds, which is a little tricky. And again, like here, you can really see in this left image that the pattern isn't really accurate in some sense. Your symmetry isn't perfect. So you know that what you've done when you made it was correct, but then when you unfold it, you get something that's sort of the idea of symmetry. And then the final one I wanted to show you, so if you're counting, we're at 7 now. The final one I want to show you is the torus, which is the orbifold for, in some sense, the easiest symmetry group, wallpaper group, which is P1. It just has 2 translations, and you can see at the right that like if you're just watching the red part of this digitally generated wallpaper pattern, this red part goes here according to this black vector, and this red part goes here according to this black vector. So you can kind of see what's happening. And to make the torus out of a piece of cloth maybe it takes some thinking about. I have to thank Sabeto Matsumoto for a good explanation of how to do this. So you want to take your cloth and then fold it into a cylinder, you know. So that part is kind of obvious, but then you have to think, like, how am I going to get this cylinder through itself? And she describes it this way. Fold it like you're folding up your sleeves. So that's a great way to make your torus. Now you can see that the fabric's really bunched up. And the result of that is that when you dye it, well, one thing is, how are you even going to pull these layers apart? But you can just pull the layers apart, actually. And then when you clamp, you're just clamping like these layers apart from these layers. But you're going to get like little local symmetries, like little local reflection lines of symmetry. And you can see that like here. And you can see that one goes here. So that's your translation symmetry. And it's really hard to see the symmetry, I think, in this one. And this is really the best example I had of dyeing this wallpaper pattern. So it's not easy to make this look great. Okay, so that's how orbifolds inform itajime Shibori dyeing. You can only get the 7 wallpaper groups. Thanks for listening to my talk. And now I'm going to have Bobby Stecker ask questions and talk about doing this with me, because he and I together dyed about 400 of these handkerchiefs. Oh, and I should introduce Bobby is a high school math teacher. So
hi, everybody.
He's going to ask some questions, and then you can ask questions.
Okay, my first question for you is, I noticed when you were showing us the dyed realizations, the pattern isn't exactly the same on every copy, and I wanted you to explain why. The different versions of the copy are slightly different than in the digital wallpaper.
Or yeah, you can just tell us too, because
Okay.
you actually know the answer.
Well, I think partially it's because when you're folding these, you have an outside and you have an inside, and the inside layers just don't get the same amount of dye as the outside, and maybe the tension on the clamp is also a little bit different once you get all the way to the inside layer. Oh, and the other thing I wanted to mention is you have to put the coins on both sides, or the die will just come in, and it has to be lined up just about perfect, or you don't get that nice circle or the washer that we saw in your pictures.
Mm-hmm.
Okay, and one more. I was very curious when I was doing a lot of the dyeing and you were doing most of the folding, and the hardest one for me to fold was the 60-degree angle.
Yeah. And so he was pointing out that, like, if you're going to do this with students, that's a fun thing to do. Oh, here are my sources, by the way. And hopefully you might have access to this page later, so I won't leave these up a long time, but we did want to highlight that this is related to Conway's stuff, and I did learn about the orbifolds from the symmetries of things. Okay, but because I knew he was going to ask me this question, we made a slide for the 60-60-60 fold, or how to make the equilateral triangle. So I just alluded to the fact that if you had folded hexaflexagons, you would know how to make that fold. But if you haven't made them, this is a nice thing to do with students anyway, to make these folds, and then to even prove that this is a 60-degree angle.
Yeah, that's a good one. Thank you.
Thanks, Bobby. Okay, so yeah, we should have questions now. Okay, so there's a question from Josh. Hey, Josh.
Josh is asking, what physical objects did you use inside the clamp for each example? Some of them look like washers, and they were washers, or lots of coins, quarters and half dollars.
Okay, so Josh, if you want to know about Shibori dyeing, there's all this information on the web about it. And you're right. So we found out that you could use coins, washers, and like jar lids. So we had ball jar lids and we used those. We also use coins, and it's so bizarre because it actually took the finish off the coins. And now I thought I was going to be able to spend them later, and now I don't know. I'm like really embarrassed that like I ruined all these coins. But anyways, yeah.
The washers you have to be careful with, because you don't want them to rust onto the...
Yeah. Well, it's interesting. So like on this one, it actually changed the color. You can see there's green on there, and that's from whatever we were using, because it was metal. It's bizarre. Yeah, my grandpa had given me all these half dollars, and I still had them, so we used those. Because the quarters, like they seem big until you start using them. You're trying to cover a piece of cloth, and then you're like bummed out because it's taking you forever.
And then, Frank, do you have two contrasting examples where you tried to make the same pattern in each, but one turned out really good while the other not so much? Yeah, I'm sure there's some of those.
Yeah, and Bobby, you were commenting that like it was really fun because we tried to we made so many of them, and we had no idea what they were going to be like when we opened them up. So we'd make them, and then we could make like 25 a day maybe, and then it was so exciting when we'd open them up, and then because you have to let the dye sit for a day, and then we'd rinse them out the next day, and it was just like, wow, what is it like?
When you unfolded it. Yeah.
Well, this one, that's just a star 2222, I think. And it's great that we have all these symmetry experts, so you guys can tell me when I'm wrong. This is star 333. I know you want two that are the same, but we just have to look at them. That's also, isn't this also a star 2222? No, this is a star 442.
Yeah.
This is a monster. But I think we have another monster here because I like that one. But they look almost the same, don't they? I don't think I brought bad examples down here because it wasn't like, oh, what I should really do for my talk is bring bad examples. But like this is an example. So you can see on this one, like, can you see that the washer's really good right here? And then nowhere else can you really see that there's a washer, except like way at the other edge.
Mm-hmm. Let's do another one.
Yeah, okay.
Okay, from Eve.
No! Oh, Eve.
Question.
Oh, Eve said, do common instructions for this technique use all 7 wallpaper groups? Are there multiple techniques for each wallpaper group? When I was starting on this, most people wouldn't ever do the Mobius band one, right? Like, who would ever think to make a Mobius band? Nobody. I don't think I saw that at all. That's super weird. And also this one where you make the cylinder, because it's super awkward to take your thing and then like, okay, well, I did a terrible job there, but then like roll it up into a cylinder. So I never saw that at all. That's so weird. Most people are going to make the flat orbifolds. So they'll make 442, and they also don't make the 333 one usually. They'll make 442 a lot, star 442 a lot, because it's easy, because most of the people doing this aren't mathematicians. I think that's what they're mostly going to do. And then a lot of people aren't using itajime. So they're going to do things, it's really fun, actually. If you would like this, you can go on Pinterest and look at Shibori, but what they're going to do is this other technique where they're stitching, and then they'll make like flowers or something like that. So they're not going to try to make a wallpaper pattern at all. They're going to make something representative of nature. Okay, Eve, I didn't do it with students. I don't usually do this kind of stuff with students because of the nature of where I teach. But I think, Eve, you would like to do it with students. The thing about doing it with students is it's really messy, but I think that if you did it with students, okay, number one, you can do it with cutting. I don't know, you can do it with paper and cutting, and Vi Hart has an awesome video about doing this. And when she does it, if you do it with paper, you know, you can make a single cut and then you can do your cone points, which is really, really cool. So hers is about, she has a Bridges paper about this, and she also has a video, which is really nice. You know, Vi Hart's stuff is always nice. And then she also has something about doing it in spheres. It's so hard. I'm not selling the samples. G4G attendees know what they're for. Carl, for the clamping hardware, I just use binder clips. It gets kind of expensive to buy all those binder clips. You can reuse them to a certain amount, and then after a while, they just kind of, like, all the paint starts coming off, and it's because of the chemicals you use to soak the fabric before dyeing. And CoM, what about the 7 freeze patterns? That's a great question. I think you should be able to make all the 7 freeze patterns, and I didn't do it yet. And it would be great, you know, they sell these really nice silk scarves that are kind of long, and I think somebody should do it, and I think you should do it, CoM. Because you live, you know, in a warm place, so you can do it.
Someone just asked in the chat, how about doing it with several colors? Is that possible?
Well, I think maybe, but not for me. I am like, so what I would say is that, so here's what happened to me. I wanted to learn how to, well, okay, so I'm a big knitter, and so one of my knitting friends was doing this indigo dyeing workshop for dyeing yarn, and the person next to me was like this really big time fiber artist, and so she was doing shibori dyeing instead, and her result was really cool, and that's how I got into this in the first place. I'm sort of think of myself as just like kind of a dyeing hack, but like somebody who is a really good dyer could probably do that. And I think it would be interesting to see then, could you do, I mean, the natural next question is like, can you do all the 2-color ones, blah, blah, right?
You'd have to be careful because the colors would start mixing.
That's right.
Basically,
so you have to do the light to the dark and all that stuff. And then there's the part where nothing ever really quite, like the part we're talking about, where like we just open it up and we're like, what's it gonna look like? We don't know, right? So, so at some point, there's the difference between the digital art and the the art where you're just like, huh, what's gonna happen? Yeah, like Josh said, it'd be really hard to get the two colors lined up if you over dye, right? Like I don't know enough about dyeing to do that. It was just kind of like this experiment, like, what could happen? It was just really, really fun. And, you know, and it was neat because I wanted to know more about orbifolds, and I found out. Nancy, no, I am not considering making face masks. We made face masks for ourselves because we're teaching in person. And we have enough to get through the week without washing them during the week. And we're just barely keeping up. It's awesome. But we are keeping up. This is a great question. Okay, Stacy says, when you have the folded fabric, is the plate clamped on the center or the corners or the edges, or is it a bit of each? Bobby did a lot of the clamping, and he is so good at it. He's like got great ideas about what to do. So tell them how you decided.
Oh, it was all of it. I think a lot of the times we would do rubber bands in the corners, and that gave us some of those neat effects. And then on the edges, try the washers or coins or jar lids. And if we still had room, we try to squeeze one in the center of the. But depending on the shape, it was hard to clamp something into the center. It was easier to clamp it onto the edge or do a rubber band around a corner.
Yeah, so hopefully from his answer, what you're getting is that we did more than one thing on a given folded piece, because we wanted a couple of different effects. And the other thing that Bobby did that was really smart, I always put on too much dye. He would like just dye one corner here and one little part there, and it made a nice negative space.
I think we've answered all the questions. Thank you very much, Carolyn. That was wonderful. I'm gonna have to try that myself. That's such a cool combination of art and math. And for those of you watching, Carolyn threw up on her reference slide this wonderful book by Conway. Will this show up here? With my, yes, The Symmetries of Things. Highly recommend this if you have any interest in just the beauties of symmetry. This goes all into the math, but it's very, at least the first half of the book is very accessible, very fun and cleverly written. And okay. Thank you all for joining us for the first of the 2020 Martin Gardner Celebration of Mind Talks. And we will see you all in about 3.5 hours for the next one. Thanks, bye-bye.